Um, Good afternoon, everyone. Now we will continue our lesson. That is atomic structure and chemical bonding. So, in morning time, Miss Krizel, she discussed about electrovalent bond. Look at here. Once again, we can check here. Magnesium contains 2 extra electrons here. Chlorine needs one electron, that's why these 2 electrons, 1 electron is given to. 1 electron is given to this second chlorine, another is given to first chlorine. That's why magnesium doesn't contain any electron in the outer orbit, that's why it is negatively charged, Mg++. But this chlorine and this chlorine, they get 1 chlorine extra and become negatively charged. So Mg++ Cl to Cl minus. So there is transfer of electrons from one atom, valence shell of one atom to another one. That's why it is called electrovalent bond. And characteristics of electrovalent compounds are also discussed. Now there is presentation from Nistara Shahi. She is going to explain about covalent bond. Right? Examples of covalent compound. Look at here. Electrons are shared and characteristics of covalent molecules. So, for presentation, let's welcome on the stage Nistara Shahi. Everybody make backbone straight and understand the matter. Don't write down. When I say write down, write down. Any lesson? Same file or different file?
Same.
Same file. So you can increase the brightness also, right?
Namaskar and very warm good afternoon to our science teacher and my dear friends. As you all know, it's me Nistara Shahi from grade 9 standing here to explain chapter 14. Half of the portion has already discussed by my friend, and now I'm going to discuss about atomic structure and chemical bondings. Covalent bond. The chemical bond that is formed by the mutual sharing of electrons between 2 atoms, each contributing equal number of electrons to the electron pair, is called a covalent bond. A covalent bond is represented by a line minus between the bonded atoms. The chemical compound or molecules formed by the covalent bonding are called covalent compounds also. Covalency. Covalent and covalency is different. Covalency is defined as the number of the electron which contributes for sharing in a covalent compound. It is always formed when 2 or more non-metallic elements combine together to form a covalent compound. Hydrogen chloride. A hydrogen atom has 1 electron in its valence shell, so it needs 1 more electron to attain stable duplet electronic conference like helium. Helium is denoted by He, capital H, small e atoms. Chloride has 7 electrons in its valence shell, so it is also need 1 electron to attain a stable octet electronic conference like that of argon. Argon is denoted by capital A and small r, so they unite together by sharing a pair of electron and a stable conference of hydrogen. Hydrogen is denoted by capital H, and chlorine. Chlorine is denoted by capital C and capital L. It attain like that of helium and argon respectively. In this way, a molecules of hydrogen chloride is formed by the covalent bonding. Methanic A methanic molecule consists of one carbon atom and four hydrogen atoms. The atomic number of carbon atom is 6 and its electron conference is 2 or 4. Its electron conference is 2 or 4. It is its electronic conference of carbon so that it has 4 valency electron. Hydrogen has 1 electron in its outermost shell. You can see here the figure of methane. Hydrogen is mixed with carbon. Water. According to the electron conference, hydrogen has 1 electron in its outermost shell and oxygen has 6 valence electron. To become stable electron conference or octet, 1 oxygen atom share a pair of valence electron from 2 hydrogen atoms. Carbon tetrachloride. The electron conference of carbon and chlorine are 2 or 4 and 2, 8, 7 respectively. Carbon needs 4 electron and chloride require 1 electron to attain the stable electron conference or octet, similar to neon and argon respectively. You can see the figure of carbon tetrachloride. Characteristic of covalent compound or molecules. 1. Covalent compound have low melting and boiling point in comparisons to electrovalent compound because they are held by weak force which can easily be overcome by graphitic diamond and ethanol alcohol. Number 2, they do not conduct electricity as they do not form ion in the aqueous solution. They are usually insoluble in water but soluble in organic solvent. Number 4, they are found in solid, liquid and gaseous stage. Number 5, they do not contain metal as the covalent bond is formed between non-metal. By saying this much, I like to conclude my presentation here. Thank you.
Thank you very much. So Nistara has brought the discussion about which one? From beginning. So children, there exists force of attraction between 2 or more atoms while forming a molecule. That force of attraction is called chemical bond. There are 3 types of chemical bond. What are they? Electrovalent bond, covalent bond and coordinate bond. But we are discussing mainly 2 bonds. What are they? Electrovalent bond and covalent bond. So in electrovalent bond, there is one metal, one non-metal. Metal donates electron to non-metal from its valence shell. there is transfer of electron. Transfer of electron in electrovalent bond. Electrovalent bond. And this electrovalent bond is also called ionic bond. It is also called ionic bond. Why? It forms ions. What does it form? Ions. What ions are formed? Like if there is NaCl, from NaCl two ions are formed, Na plus and Cl minus. This is cation, this is anion. Positively charged ion, negatively charged ion. So when there is a bond between metal and non-metal, when there is a bond between metal and non-metal, then that type of bond is called electrovalent bond or ionic bond. There is transfer of electron. The next one is covalent bond. In covalent bond, the force of attraction is developed by mutually sharing the electrons or mutual sharing of electrons between two atoms. Suppose we have discussed already about sets. So what type of set is this? This is overlapping set, right? And what type of set is this? Disjoint set. So electrovalent bond is like disjoint set, and covalent bond is like what I said, overlapping sets. So electrons are shared, either one pair of electrons are shared, or two pairs of electrons are shared, or three pairs of electrons are shared. This line indicates how many electrons are shared. If single line is there, like if I write there n single line, single line, single line, in between nitrogen and hydrogen, how many electrons are shared? One pair are shared. Here also one pair are shared. Here also one pair are shared. What if I write here O double bond O? How many electrons are shared? Two pairs, right? Two pairs are shared. If I write here N triple bond N, how many electrons are shared? Three pairs are shared. Single pair, double pair, triple pair. If I write here C H H H H, so in between carbon and hydrogen, how many pairs are shared? One pair here, one pair here, one pair here, one pair here. If there is mutual sharing of electrons, then all the atoms are of non-metals. What are they? Non-metals. So carbon and hydrogen both are non-metal. Here nitrogen and hydrogen both are non-metal. And carbon and oxygen, they are also non-metal, right? Hydrogen and oxygen, they are non-metal. So here we have to keep in mind, covalent bond exists between what? Non-metal and non-metal. Non-metal and non-metal. Okay? So they contribute equal number of electrons. If one atom contributes one electron, another also contributes one. If one contributes two, another also contributes two. That is the thing. And those molecules which are formed by covalent bonding, they are called covalent compound. If there is presence of covalent bonding, that is called covalent compound. Right? Next one, during covalent bond, during the formation of covalent bond, some number of electrons are shared. So how many electrons are shared? That is called, what do you call it? Covalency. If one electron is shared, covalency is 1. If two are shared, covalency is 2. If three are shared, covalency is 3. For example, if I write here H, H, here is single bond is here, right? Means how many electrons are shared? 1. That covalency of hydrogen is 1. Here are some examples. Examples of covalent compound, hydrogen chloride. Diagram you can see here. Oh, hydrogen chloride diagram, see, forgot to mention. In hydrogen chloride, I can just show you. Hydrogen, hydrogen and chlorine. 17 proton, 18 neutron. Hydrogen 1 proton only. 1 electron, 1 electron. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Why did I show you differently? So that it will be easy for you, right? So this is the electron of hydrogen. This is the electron of chlorine. Now they are sharing this one pair of electrons. For hydrogen, 1, 2. It will be in which state? Which state? Duplet. For this one, 1, 2, 3, 4, 5, 6, 7, 8. How many? Octet. To be stable, either they should be in duplet or octet. So, by sharing electron, hydrogen remains in duplet state, chlorine remains in octet state. So, we can show this like this: H single bond Cl. H single bond Cl. So, means one pair of electrons are shared. Next one, carbon. Carbon at the center. Now, first two electrons. Here is hydrogen, here is hydrogen, here is hydrogen, here is hydrogen. H, 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 H. Then two electrons are shared here, two are shared here, two are shared here. So this can be written as C, H, 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 H. So here is sharing of electrons. In between carbon and hydrogen, one pair of electron is shared. Here also one pair, one pair, one pair. So because that, hydrogen will be in duplet, 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 duplet. Carbon will be in octet. Octet means at last how many will be there? 8 electrons. So here is sharing of electrons. So this is covalent bond. Methane CH4 we have done. Here is sharing like this. You can notice here carbon. Water also similar one. Now the last portion is here. Characteristics of covalent compounds. How many characteristics are given? What is the first one? They have low melting point and boiling point. They can be changed into liquid very low temperature. They can be converted to gas at low temperature. Means melting point, boiling point low. They do not conduct electricity because they do not contain ion. No ions are present here. In carbon dioxide, we cannot make C++ and O minus. No ions are here, so they do not conduct electricity. They are insoluble in water. Electrovalent bonds are soluble in water, and they are soluble in organic solvent like petrol. Organic solvent means those things which are obtained from living things. Petrol, mobile, ether, alcohol we obtain from living things. So they are soluble, and mainly they are found in solid, liquid and gaseous. But electrovalent compounds are found in solid state only. And the next one, what is here? They do not contain metal. There is presence of non-metals, right? So that is all about these two bonds. Which are the two bonds? Electrovalent bond and covalent bond, right? So once again, just give it a glance and make very lovely notes. Understood? Okay. Action.